Okay, so today's video is going to be about quantum mechanics. In quantum mechanics, we will talk about superposition in detail. Okay, so wait, what the quantum mechanics? Sorry, bright color. Quantum mechanics. Okay, in quantum mechanics, we'll talk about superposition in detail. Superposition. Okay, so we will start off with the an interferometer, which is known as Mach-Zehnder interferometer. Interferometer. Okay, this interferometer shows that is the experiment is that there is a beam, okay, and goes through a beam splitter. Okay, a beam splitter, and it goes, one transmits to a top, the other one is split into the bottom, and on both sides, or both sides of the vertical, we have two mirrors, mirror 1 and mirror 2. Okay, then they are reflected off. We will say that these two mirrors have no don't affect any, don't affect this light beam, okay, when it's reflected, so no effect at the time of reflection. Then again, uh, okay, then again it's split, one goes to top and then one goes to bottom. Okay, and here we have two, we want to detect them. Okay, so we have two detectors, D1 and D2, detector 1, detector 2. So here this is the input, and so what we say is that when light was sent to the light beam splitter, it split in such a way that half of the light beam went to the top and half went to the bottom. Or in quantum mechanics, we can say that it went both. So in terms of quantum mechanics, I will write it as it went in both up and top at the same time. This is known as superposition. This is what our topic is, superposition. Okay, so in classical physics, we say that it half of it the light beam went up, or half of the photons went up and half of the photons went down, or that's classical physics, which would be absurd, because in quantum mechanics it's the opposite. What is it goes both up and down. It's the same for both. Okay, so then uh then what do we say? So here we say, so first of all, let's imagine this light beam is a single photon. Okay, so this single photon is nothing but sum of photon sum of photon in, it's a superposition, right? Superposition, sum of photon in top, no, not sum of photon, superposition of photon, which is upper beam or I'll just write symbols, not letters. Upper beam plus lower beam. Okay, so then uh, what's happening here is that the single photon before is nothing but the sum of the photon in upper and lower, superposition sum of upper and lower, which gives you the single photon superposition. Okay, so to show an example how this might work in classical physics, I'm pretty sure you all know about vectors. Okay, so we can say this is nothing but a vector, right? Okay, so shit, sorry. Okay, so this is first, this is second, 1 and 2, they give a same answer. Again, it could be this vector as well, which gives us the same resultant, and many others and so on. Okay, but the answer in the resultant you would get the same. So we could say all of these give same answer in terms of superposition, or if I write in superposition the vectors plus the each vector superposition, even though they're different, gives a single output, a single probability. Okay, in the end we get the same answer. Okay, so what we say is that, let's suppose if we have two vectors, I will take same thing, b and this, so its superposition over here will be a plus b, superposition state of being in a plus in b, such that if we measure some of the properties of a, we get a small a, and if we measure some of the properties of b, any property, we get sorry, we get small b. Okay, so in when we say that, let's suppose this superposition state, this is a superposition state and I want to measure it. Okay, and I will give it a, yeah, I'll put it in superposition, so it will be this. This is the wrong one, it should be separate. This not right now is not in superposition state, because when we put it in superposition state we have to give some complex constants. Okay, so here these two are acting as parameters, not constants, parameters. Okay, so what we see is that these are now, right now we can say it's in a superposition position state. So but then okay, fine. So in classical physics there's something that if we measure some property and we can get any value in between, either exact value, lower value, or in between, in between. Okay, value in superposition in classical physics, classical mechanics. So but then again, In quantum mechanics, that's not the case. Okay, in quantum mechanics, when measured, when measured, we get we get one, either A or B. It's either one of them. We cannot get A and B, A some probability of A and some probability of B, but that the wave function breaks and we get either one. Okay, so we say that probability of A is is pro- is proportional to norm of alpha, and probability of B is proportional to norm of beta. Okay, such that again, if you do uh, A, you work on A, you'll get A. If you work on B, you get B. So you get either one exactly. You don't get any value in between. That's what quantum mechanics is about. Whenever you are measuring any state, any superposition state, no matter what it is about, on measurement, on observation, that state will break. The superposition, superimposing will break, and you get one single exact value. So that is somewhere can be known as coherence. That you measure, you there's some there's some uh, changes in the environment, and that causes the quantum wave function to break. So then let's have an assumption. Let's have a physical assumption. Okay, we say that a superposition of a state imposing on itself, imposing on itself, on itself, doesn't change the physics, does not change physics. Okay, then what what are we talking about? We say that any state, no matter what it has, they is all they all equal. They are equal. Okay, so how could we illustrate it? Okay, let's suppose we have a photon which is gone through a polarizer. Okay, we say that it's gone through a polarizer. Sorry. Okay, so what we say is, if I want to wait, where was my favorite color over here? Yeah, this one. Yeah. So what we say is, that in terms of diagonally, this is y, this is x. Okay, so in a superposition state or a diagonal state, sorry, diagonal, okay, which is 45-degree angle, we'll assume it as superposition. Okay, so what we say is that uh, so photon is alpha photon alpha dot x is sum of it is in x state plus sum of it is in what do you call that, y state, which is alpha. Okay, so when we have a parameter, one complex parameter, we have two real roots, but here we have two complex parameters, so we have four real roots, parameters, four real parameters. Okay, so that's not like adding up with our what do you call that, our understanding. What our understanding says is that we should only have two real parameters. Okay, so what could we do? We could say that if we divide or multiply this whole thing by 1 over alpha, or 1 over alpha, now guess what we get? We get photon in x plus beta over alpha photon in y. This beta over alpha get is nothing but beta over alpha is one single parameter, and this gives us two real roots, two real roots. So now we have a correct one. Okay, because we don't want four real parameters, we want two real parameters, out of which either one of them is selected. On four real parameter on four real parameter give two answer. Okay, but give two answers, but QM wants one answer. Okay, which is again what it is. Wait, let me get onto it. Which is one, so two real parameter out of which one is selected. Okay, so what do we say? So we look at one of the properties of particles in quantum mechanics, which is spins. Okay, so what is spin? Spin is actually a property of a particle. It's a weird property, by the way. It's so weird. Like what I know about is that when a normal spin at macro level, macroscopic level, spin is something which happens because of what you're doing. Okay, but at microscopic level, the particles are spinning not because of what they're doing, but because of what they are. Okay, so that's a separate topic. So here what this particle actually is doing is it's spinning in, I would if I would well, if I were to say that spinning in one direction, I would be wrong, because if it's, let's suppose we're spinning in its z axis, okay. So we say that this object or this particle is spinning both in up direction plus it's in the bottom direction, okay. So in superposition state, it is, this is what superposition state is. Well, let me add over here as well. Superposition state, superposition state, where superposition state, this is superposition state again, okay. So here superposition state is that it's in both and up until observed, until observed on observation, observed on observation, superposition breaks and we get either up or down, but here we will get 50 50, that if we have 1000, maybe 495 nearby, they will be close to each other, they will have half up half down, and so on. So what you will see is that, what you will see is that this is what it is, this is what it is, this, okay. So this is what superposition actually in terms of spin is. The particle is actually spinning in z direction, both up and down until it's observed, but the moment you observe it, we will have either spin down or spin up, okay. So what we do is, what could we do, what could we do, what could we do, not what we could do, I suppose. Now that particle, we measure that particle in x direction. Again you will observe that half of them will be in the x upper direction, x positive, and half of them will be in the bottom direction, not in both, it will positive, what am I doing, it in both direction, it's half of them will be in the upper part and half of them will be in the lower part along x-axis if we measure them, okay. So in terms of quantum quantum what do you call this, quantum, what do we call this, what do we call this, quantum computers, okay. A mixed or a superposition state, it came into my mind, so I would thought, let's now, why not add it. A superposition state will become psi of x, or it will be in a Hadamard gate. We'll use a Hadamard gate to put it in superposition state of in this way, okay. This could also be changed to get probability high of preferred answer, preferred value, okay, which could be that we make it 3 square root of 3 over 2 for the upper one if you want the upper one, and 1 over 2 for the bottom one, Do we get the same? Do we get 1 if we do this? Let me check. Square root of 3 over square root of 3 over 2 plus not square plus 1 over 2 square, not this 1 over 2. We have 1 over this. Okay, wait. Let me do. Nope, we don't get that. So what about if we do this? Over here. 2. Okay, crap, I forgot. Let me try something different. Plus 1 over 2. Sorry, let me add a square root. Sorry for this calculation timing, but it will pay off in a moment. 1 over square root of 2. Okay, we'll see later on. Okay, but just as example, it doesn't add up to 1. Just for the head start, doesn't add up to 1. My math is weak, I'm sorry. So yeah, here this is the only thing for which this is all about, what superposition is all about. Okay, that's it. Thank